Hello, everyone. Welcome. I know it's the last day of the conference and there have been some great presentations. So we'll keep our talk fast-paced and interesting. Mastering OpenSearch Benchmark, advanced techniques for power users. Okay, yeah. Advanced users or power users. What exactly is that? Is that an expert user or a jack of all trades? Well, these pictures are somewhat like OpenSearch Benchmark itself. It's a power application and is also chock full of features that even the expert users might not be aware of. So fear not, we don't expect any pre-existing knowledge about OpenSearch Benchmark. We'll cover some of the basics, but that being said, there have been a couple of great talks on OpenSearch Benchmark just a little while ago. So there are a couple of YouTube videos that you can go back and check by Ian Huang and Michael Oviedo. So over here. Next. Yeah, let me introduce myself. My name is Govind Kamat. I work on benchmarking tools at AWS. Prior to this, I've been somewhat around the block, having worked on hardware simulators, language parsers, code generators, processor models, and computer systems. My co-presenter is Rishabh Singh, also from AWS. He's a versatile engineer, having worked on infrastructure tooling, release engineering, and performance benchmarking. He has made several substantial contributions to OpenSearch Benchmark and is currently a maintainer on the project. How many of you have seen the benchmarking charts, OpenSearch performance benchmark charts that are available at benchmarks.opensearch? Well, I think we've got quite a few here. So this is the face behind those charts. So you can corral him after the talk if you have any questions about it. So the agenda that we have a laundry list of items that fall into a few different categories. We'll start with customizing OSB workloads to precisely your needs. We'll talk a little bit about telemetry devices to grab information from the target cluster. Then there is a topic that's near and dear to many people's hearts, which is sort of rolling your own workload. We'll also talk about concurrent queries and carrying out tests that run for a very long time. If we have time, we'll cover a few miscellaneous topics. Next. Yeah, so as I promised, here's a very brief overview of OpenSearch Benchmark. So it is a client application, just like how you personally would probably use OpenSearch. So when OpenSearch Benchmark operates, it is completely distinct from the target cluster. In this schematic, your cluster is on the right side with 3 data nodes, and OpenSearch Benchmark has been installed on a separate node on the left, the load generation host. It also comes packaged with a few different workloads. You can choose the one that you want. There are 3 examples over here. And at the core, all it does is it sends a sequence of queries to the cluster, receives the responses, and times them. So at the end of your test run, it collates the information that it has received. Optionally, it will save that in a metric store, which you can see on the bottom of the screen. And based upon the data, it will present to you latency and throughput information. So that is pretty much what OpenSearch Benchmark is in a nutshell. But obviously, under the covers, there's a lot more complexity and sophistication. You can look at metrics in various different categories with mean, median, and a lot of other statistical information. So here is an example test run, again, courtesy of Michael's talk from before. So it goes through a few different steps where you delete an index, create an index, and then once that's set up, you go ahead and ingest some data into the target cluster. Once the data has been primed, then you run your queries, and then you can take a look at the results, which show up as latency and throughput numbers just after the screen. Yeah, right over there. So that should be all you need to know about OpenSearch Benchmark to get started here. And we'll just launch into the talk, the first part being customizing the workload. So as I said, OpenSearch Benchmark comes packaged with several different workloads in various different domains, which serve well. There have been talks about customizing, building custom workloads using create workload and other mechanisms. But for here, what we are looking at is when you have a workload, how do you really customize it and change it? So there are a few different ways. So if you have a workload that's part of the OSB suite, you would see essentially that the workload specification is a JSON file. It's pretty much standard JSON. JSON doesn't allow you comments and so on, so it's a very limited kind of language from that perspective. But if you want to go ahead and make changes to the JSON, that's a little bit trickier. So the way OpenSearch Benchmark does is that it uses Jinja as a templating language. So essentially that's pretty much like a preprocessor. If you have used C and so on, it's like the C preprocessor just before compiling the C program. So what you have is these double braces that really are not a pure JSON, as you know. So the first line, you are trying to set the number of shards. And what it does is that the variable that is number of shards on the right side is set to a default value of 5 unless you have specified a particular value. And how do you go and specify the value? The third line down there which says when you run OpenSearch Benchmark, you can provide a command line argument which says workload parameters, and you say number of shards 10. In that case, the number of shards will get overridden to 10. Similarly, there are a lot of other variables that you would see in any workload. And whenever you see these double braces, you can be assured that it's part of something that gets processed by Jinja. So over here, you look at the cache enabled where you set it to false, or you can change it if you want to. And Jinja is not a very complex language, so I won't go into all the details, but it has the standard complement of programming statements like if statements, you have a with statement, and so on and so forth. And you can have macros where you include other files, which is the benchmark.collect line, which is the second last line on the page here, where you're loading other material from a separate JSON file. Next one. Yeah, so that's all very well and good, but whenever you run a workload, the queries that are part of the workload are pretty much static. They don't change. So sometimes you would like to say, you might think, wouldn't it be nice if I were able to change the query? How do I go about doing that? And that's where custom parameter sources come in. So just to give you a little bit of context, how do you really specify a query in OpenSearch Benchmark? There are two parts. There is an operations section and a test procedures section. So the first part is to define your operation. What is it going to do? And that's fairly straightforward. Whenever you go ahead and access an OpenSearch cluster, you use the standard API, you might send a curl request. And if you look at the last 3 lines over here where it gives you the body of the query, this is a simple match all query. It's exactly the same thing that you would do if you were to send a curl request. And the first couple of lines are a little bit of addition where you say, I want to target the logs index. And in this particular case, you have got a wildcard. So it will be targeting all indices that begin with logs. And you can specify the operation type. That's sort of an indication to OSB that it wants to use the search module to do this job. So that's pretty much an operation. Now, once you've defined your operations, you can then string them together with a test procedure. The test procedure just gives you a list of all the operations that need to be invoked in succession. Here's just one over here, but you would probably have a sequence of them. And in this case, what we are doing is it is essentially the same operation that you had before, the match all operation. And we provide a little bit of additional information saying we want to do 200 warm-up iterations, and then at that point we start the measurements and do the test iterations, 100 test iterations. And OSB will carry out these test iterations, and then there'll be some variance. It'll collect all the information and then say, okay, this is the max, this is the min, this is the median, and so on and so forth. And we are running this with one client. So all of this is configurable. So let's go to the next one. Okay. So now that you know how OSB actually carries out these queries, and the same sort of thing applies to ingestion as well, by the way. So let's say you want to make your query dynamic. You don't want to sort of hard code it. So how do we go about doing that? So the secret is in the third line over here where you say, okay, you tell OSB, I want you to grab my query, not from some static place, but I want to sort of have, I fancy myself to be a programmer, so I want to program my query. So how do we do that? And here we say the query should come from this parameter source, which is the example query param source. And whenever you write a function, you probably want to provide some arguments to the function. Say, okay, this is what it's going to vary. And so that's the status values. So this is HTTP status values. So we are going to say that please write, I want to have a query that changes the status value from time to time between 200, 304, and 404. So standard HTTP status values. So now that you have that information, how do you actually activate it? In your workload directory, the OSB workloads, typically you may not have Python files there, but if there are, or even if there's not one, you create a file called workload.py, and in that file, what you do is you register this parameter source that you're creating. So we mentioned in the previous file that it's going to be called example query param source, which is what you have there, and you're mapping it to a Python function, and the Python function is the generate query with this random status, right? So that generate query with random status is this Python function over here. So in sequence, the first couple of lines there, what it's doing, it's just setting the stage for the rest of the function. So it grabs there are a few arguments where you have the workload, the params, and the rest of the arguments. The workload is simply a specification of the entire OSB workload, and you are following it with the parameters that get passed in. So remember that in the previous slide, we passed these HTTP status values to 200, 404, and so on and so forth. That comes from the status value. They say, okay, grab the status values, and we'll store them in this variable. And the core of the function is just the middle of the whole routine over here, where you say it's exactly similar to what you saw before. It's the curl query that you would send. You're sending in the body a term query, and the status, you're not hard coding. You're saying, okay, the status is going to be a random choice among these status values. So what Python will do is it will just go through these numbers and just not necessarily round robin, it will go through a random choice of those values and just stick that in. So this query is now created and gets run by OSB. You optionally can, since you, as I said, fancy yourself to be at least a basic programmer, or you might be an expert at it, you might say, I want to log it, debug it, and so on. So you can put in the logging message, and it will log this in the benchmark log file. But be aware that any extra stuff that you might put in here might impact your query latencies. I mean, this is in the critical path, so your function should be pretty optimal or fast if you're trying to do this. So the last line returns the body. So with this, you're pretty much armed with power to do anything that you choose with creating your queries. So where would you use it? Well, as we talked about earlier, you might want to have a dynamic query where you say, I want to have random terms. I don't want to have static terms. I know what the mix of terms is, and I might want to get these terms from either a file, or maybe you go and look at the data corpus itself. I mean, you know what you have ingested, and you say these are the common terms that people are going to be looking for. If it is fruits, for example, maybe you don't want to have a hard-coded query with just avocados, but you want to have avocados, mangoes, and pears, and you say these are the ones that I want to grab in my query. You can change the behavior of a query over time. You could have a query that's completely flexible. I mean, in OpenSearch, you've got queries with different Boolean clauses, with filters, and you might say, I want to have a filter with multiple arms, not just one clause, but maybe 3 clauses. You can do anything that you want to do. You might want to have a field that changes from low cardinality to high cardinality fields. I mean, and those can be very different in the way of performance. So you can model a real-life scenario with this scheme. So now that you know how to create a dynamic query, there is another technique that you might want to use sort of under the hood once in a while. The OpenSearch API is pretty complex and sophisticated. There are a lot of different functions over there. Some of them may not be that common. They may be less used. There might be a new API function that gets added. So you want to sort of add that to your workload. It's not already supported. If the API doesn't have direct support in OSB, if you want to really go ahead and use it, you need to be sophisticated enough to add a new module to OSB. Like that's called a runner. That can be quite involved. You need to get a PR, raise a PR, and get that all in. So let's see how you can do that pretty quickly. So you can go into accessing the curl API directly through OSB via a raw request. So what you do over here, again, the body of the JSON over here is pretty straightforward. It's pretty much a curl request where you're doing a put request against the cluster against a particular index. So we're trying to modify the index settings. And this is the logs underscore logs 18, 19, 98 index. And we are modifying the settings to change the number of replicas. So you can go ahead and change the number of replicas dynamically. You can do pretty much, you can modify anything else in the index settings. And this is, again, not restricted to index settings. You could go ahead and change pipeline, access the pipeline API or anything else. So once you do that, you can make this part of your workload. You can time it. You can do what you want with it. So it unleashes the power of OpenSearch Benchmark right at the low level. You may not want to do this commonly, but it's good to know about it. Yeah, so now that we have some ideas about how to modify our workload, let's move on to the next topic, which is telemetry. As I mentioned before, OpenSearch Benchmark is primarily a client-side application. It doesn't run on your cluster. You don't install it on your cluster nodes. So given that it doesn't have much insight into what is happening on the cluster side, so a lot of people might come back and ask us, want to know, what is happening on the cluster? What is the CPU utilization like? What is the JVM like? I mean, I'm running this high cardinality query, which is sort of bringing the cluster down to its knees. I need to have some insight of what's going on over there. And we would go back and say, well, OSB is a client-side application. It doesn't have that information. So telemetry allows you to do that. Now, OpenSearch is pretty sophisticated. It has a number of statistics APIs and so on that run on the cluster. And OSB can leverage that and grab that information. So via telemetry, you can typically access these OpenSearch metrics. The other area for telemetry is to get Java metrics. Now, obviously, you know that OpenSearch runs on the JVM, and the Java virtual machine has got a lot of data to do with garbage collection and other statistics with how the heap operates and so on and so forth. You can get logging information as well. So you can get Java telemetry too. When you run telemetry to get OpenSearch metrics, that doesn't get presented in the summary at the end of the workload, summary of the test run. I mean, when you go ahead and run, let's say, 5 queries, you typically get information about these 5 queries. But now when you're talking about telemetry, there's a ton of information to do with pretty much everything. CPU utilization, memory, thread pools, so on and so forth. So it won't fit on there. So the way you would go ahead and do that is to store it into the metric store that I showed in the first schematic. And later on, you can go back and extract data from the metric store and visualize it and do what you want with it. For the Java metrics, the expectation is that you have some understanding of what Java can do, how to analyze this information. For example, you might get GC logging information or the Java flight recorder information, and you should have an understanding of the tools to process these kind of things like heap dumps. So let's go to the next one. So yeah, just a summary of the devices. There are multiple options that OSB has. These telemetry devices is just a sampling of them. So as I said, OpenSearch telemetry, there's node stats, shard stats, and so on and so forth. Most likely, you would probably be using node stats commonly because that gives you all the detail on all the nodes, target data nodes, the CPU utilization and the memory and so on and so forth. So probably that's the most commonly used one. But there are a lot of other ones that you can analyze if you so choose. And on the Java side, you got heap dump, garbage collection, JFR, and so on. Next one. So when you go ahead and want to use telemetry, how do you do that? It is pretty straightforward. There is a flag in OpenSearch Benchmark which it says where you can choose to use node stats. Telemetry node stats will do the job. If you want to, for example, use the Java telemetry, you would use telemetry JFR for the Java flight recorder. And each of these has its own set of arguments. You can go and look in the manual for more detail. It's true that the manual is a little bit limited. We've been working actively on adding more information to it, but you will be able to get this data from there. So for telemetry node stats, you could go and say, yeah, this is very big, but I don't want to get thread pool information, so please don't give me that. So you turn that off. So that's a flag over here. on the telemetry params. Similarly, for garbage collection logging, you can say, I want to get log lines with GC info tag and the save point info tag and so on and so forth. So there are multiple options. These are the same ones that the the JVM uses. So you can use the same type of flags. Just to give you an idea of what the output looks like, I mean, again, it's not presented in this form. This is the way it goes into the metric store. It's a pretty large JSON document. So I'm presenting a subset of it here. For node stats telemetry, it shows you the garbage collection information. It gives you information about the test run that it actually is presenting the information about. The test procedure is append no conflicts, and similarly, it gives you information about the cores, the clusters, and so on and so forth. So based upon that, you can get information about node stats. And similarly, the next one is for shard stats. If you ran shard stats, you'd probably get a document like this, which is much smaller. Gives you information about the shard setup and the segment count. Next one. So I think there's a lot more data for telemetry, and I don't want to make this a talk about telemetry itself. So at this point, I will hand this over to Rishabh, who will give you a lot more information on as I said, items that are near and dear to your heart, like rolling your own workload.
All right.
Yeah, Rishabh.
Thanks, Govind. Some really good points that you discussed. So the next part is less of a talk. It's more of a crash course in using advanced features of OpenSearch Benchmark. They are much less talked about, but I think they're really powerful and can really take your user experience to the next level. So the first thing is custom workloads. So in our past 2 talks that we have done in this conference, the most common question was, having all the prepackaged workloads in Benchmark is good to have, but what if I want to use OpenSearch Benchmark with my own queries on my own data? Can I do that? And the answer is yes. It's so custom workloads, they leverage existing data in your clusters. They're very easy to create, that we'll see in the next slide. And you can easily replicate your production traffic. You can take it as high as possible. And these can come really handy for you to run game day tests, load testing, stress testing. You're just moving from different providers and you want to see how each of them fare against each other, or you just planning to migrate from one version to the next version. And you want to see, how the performance is impacted in the newer version before you make a decision. You can use this with your exact production queries. So how do you create it? It's as simple as creating a single file called workload.json. And the structure already, so I think most of this is already covered in Govind's part. So it has 3 major categories, which is 1, description. It's good to have, it's optional. Next comes operations. In operations, you define the exact queries that you want to test. So these can be your multiple production queries that you have pinpointed that you want to stress test with. And test procedures is how you want to test them, like in which order. So this will have the schedule, which we already covered. So this is like a sample workload.json. So you can see it's just one file, and it has operations. It has 2 operations. You can have 20 if you want, or 200. It has a match all query. It has a term query. And then it has a test procedure that defines the schedule. The schedule has it runs the match all query first. It runs it for 1,000 iterations with maintaining a throughput of 10 requests per second. You can make it 1,000 if you want to. And the next, it runs a term query, again with the same iteration at much higher throughput, which is 15 requests per second. How do you run it? It's as simple as this. OpenSearch Benchmark give you a workload path and your target host. That's it. And Benchmark will do the rest. It'll read your file, it'll load it, and then it'll execute the schedule as you have mentioned it. So yeah, you might think okay, that's all tied up to the search part of it. What about if I want to? So normally you wouldn't simulate production traffic on your production cluster. You would rather have the same data in another cluster and then simulate the same kind of traffic. So how you can do that? So our colleague Ian already gave a talk on how you can extract your production data from your existing cluster and create a corpus out of it, and then ingest that in your parallel cluster or in your QA environment and run the same search workload if you want to. So yeah, he goes like really deep into it and how you can just take your data from production and put somewhere else. Cool. The next part is, it's a very common question that comes to us. Like, okay, I mean, if you go and look at the workloads that we have, everything is pretty like similar, along the similar lines, where the test procedure would just go ahead and create an index. It would ingest the data for you, and then it will run a bunch of queries in sequence. But that's not how production works. In production environment, you can have a constant stream of ingestion coming in, or even updates and deletes coming in, force merges happening, and along with all this, you have tons of search queries coming in, and you want to like simulate. You would rather simulate that than to run everything in sequence, because that doesn't make sense in production. So yes, OpenSearch provides this custom operation called parallel. So you can use this custom operation to run operations concurrently, simulate more realistic traffic patterns on your cluster. Like I said, you can do either indexing, updating data while the search is happening, or just in case if it's a read-heavy cluster for you and you have like 20 different queries that run at different throughput, you can put all of them in the parallel block, and OpenSearch will run all of them in parallel in defined throughput mode. And also, you can run admin tasks in this parallel block, like force merge happening. So you want to see, like, you have a frequent force merge happening, and you want to see how it impacts your search query latencies. It's very much possible. This is an example. Again, this is the next workload JSON file that you can see. In this case, we are using the parallel block, and the parallel block has another block called tasks. Inside this, you define all the operations that you want to run concurrently. So in this example, you can see we are doing an index append, which is ingestion happening, and at the same time, we are running match all queries with throughput of 20. You can take it to 2,000 if you want to in your production cluster. So this is a very simple example. You can expand this to very much having updates happening, deletes happening, and you have like 20 different queries also like running at the same time. As long as your client is big enough to support your load, it's possible to run everything concurrently and simulate the exact traffic pattern that you get in your production cluster. Next part that I want to cover, I think Govind covered most of it, but I just wanted to cover the other side of it, which is not much talked about. So if you go, again, if you look at our workloads, most of them you'll see in the schedule is all iteration space. Basically, all the schedules have like iterations and warm-up iterations, which just tells each query how many times you want to run it. But I got a lot of questions from teams like saying, it's good to have, but I want to run a query for 12 hours, or maybe I want to run it for like 4 or 5 days to see like how it's impacting my CPU resource usage. Also, like I want to like, I think I have a memory leak happening, which actually only comes alive when I have a very high cardinality query running for an extended period of time. And we have, so how can I run longevity tests? So before I go into that, yeah, test schedules, they are used in test procedure block. They are like a workout plan for your database. They run sequentially by default, but in the previous slide we saw you can run them in parallel. And they're configurable at each operation level, meaning like each of these queries have their own throughput defined and own iteration defined. So Benchmark supports 2 major kinds of schedules. One is iteration-based that we already talked about, runs a specified task for a fixed number of times for each client. The key params that you can see, iterations and warm-up iterations. I don't think we covered warm-up iterations. So warm-up iterations actually help you to stabilize your cluster. So say if you have a new cluster came up and it doesn't have all the optimizations applied to it before, unless you run some queries on it, ingest data on it. So warm-up iterations help you to bring your cluster at a very optimum level with all the optimization applied. And all the metrics that OSB generates during warm-up time, it doesn't use it for final result calculation. So the final results that you see, like mean, median, or P90, P50 calculations, they all happen only when iterations, when the prod iterations are happening, not during warm-up iterations. So moving on to the time-based, so yeah, we have another schedule called time-based schedule, where instead of iterations, you can define time period at each operation level. They run the task continuously for the time you define, Instead of iterations, you would use time period, where you would define how long you want to run those operations. Could be a few seconds to up to days if you want to. And it also has the warm-up time period option, where you just want to let the cluster warm up before your actual processing starts and metrics start getting generated. And you can mix and match them. Again, this is one another demo workload where you have a default query running in iteration mode, and you have a term query running in warm-up time period mode. So far, yeah, I mean, OSB, we've been talking about executing new tests. After you have all the data, you would want a comparison, right? I mean, you're running tests on 2.17, and then you're running tests on 2.19, and you want to make a decision whether is it suitable for me or not. So you wouldn't want to go and grab all the data and put it in a CSV file and then do a manual comparison. You would want like some kind of tooling that can easily help you identify how each operation fares in two different versions or two different clusters. So Benchmark supports a utility called compare, which you can use to easily compare results between test executions. So by test execution, I mean like when you run, or like I think in the second or third slide where Govind showed example to run the benchmark. So each benchmark, it creates a unique text execution ID that compare commands uses to compare. So yeah, you can use it for performance regression, detection, release validation. We use a lot during release validation when we are doing a next release. We do a lot of comparison with the current GA version and the upcoming GA version to make a sound decision whether we should go ahead with this release or not if we see any performance regression. And A and B testing, like for example, you have a same cluster, but you want to play with different index settings, cluster settings, even like JVM parameter, tweak some JVM parameters to see how it impacts. You can use that for that. And again, it's as simple as running OpenSearch Benchmark compare. You give the baseline ID, which is your existing cluster, and the contender is the one that you are evaluating.
2 minutes.
Okay. Cool. And this is how the diff would look like. So at the end of the run, OpenSearch Benchmark would give you an output like this. You can see just apart from the operations, it also like compares a lot other metrics like store size, translog size, how much time the GC is taking in each one. And yeah, and then on the left, you'll have the baseline numbers. On the right side, you have the contender number. And in the, I think 1, 2, 3, 4, yeah, 5. In the fourth block, you have all the diff. So green means, it color codes for you. So you can like the green means all good in your contender, like you're the one that you're evaluating. If it's red, yeah, I mean, you might want to look at if it's beyond certain threshold. So for now, it just calculates a simple difference. We have a feature in progress where we would also have it represented in percentage-wise. If you want, like it can be really helpful to make quick decisions. So key takeaways from our talk is, yeah, workloads are flexible and highly configurable. So like I think all the things that Govind talked about, Ginger templating and parameter source, apply to your custom workload as well. I think I did not mention that there, yeah. So if you have a query that you would want to run with 1,000 different terms in your own custom workload, it's all applicable there. Measure not just latencies and throughput, but much more inside your cluster. Like it goes for telemetry, where you also want to track the search thread pools, the CPU usage, JVM utilization, and all the other like cluster metrics for your benchmark runs. Use it to replicate your production traffic, simulate concurrent traffic, and run longevity tests with the time period schedule. So that is all I think we have for you in this talk. I hope like, yeah, you make use of these features. And if you have any questions, you're free to take. Yes, I think Govind talked about a data store. So OpenSearch Benchmark comes with a configuration file. So by default, if you don't change anything, it stores everything in memory and flushes out, and it just gives you the final result, which it stores. But in case if you want to store all the granular metrics in a separate data store, you can hook another OpenSearch cluster to it. So what it'll do, it'll sample each second, and it'll flush out every 30 seconds, I guess, to the data store. So you can track live as your traffic is increasing. You can track live CPU, you can track live JVM, live latency, live throughput, everything. And you can use dashboards over your OpenSearch or any other tool. Yeah. Yes. So there's a feature called detailed analysis or enable detailed analysis that should be in our documentation. I don't have the exact keyword, but what happens if you enable that, it also stores took time for each query. It will not be shown in the final results, but like I said, in the data store, you can see it you can see it real time if you want to, how each query is performing at took time level.
And there is a way to correlate the query with the name tag that you assign.
Yes, it supports, there's a flag called user tags where you can assign your own metadata to your run to easily identify and use it during visualizations. Yeah, that comes really handy if you want to compare a lot of runs and you just want to say, okay, this is my this run, this is my test run 2, test run 3. You can easily filter out and.
Per different type of queries that you have in your workload.
Yes, yes. It has the metadata for it, yeah.
Yeah, Rishabh has used that for the nightly performance runs and the charts that he's doing. It's a subset of that, but yeah, he is the expert on getting all of that.
For the took time, there's a catch saying, how benchmark works is like it sends the request and it gets a response back, and the final service time or latency that you see reports on that basis. So when it does when you enable the detailed analysis, it does take a very fraction of microseconds maybe to analyze the took time, the response payload, and extract took time and load it. So you may or may not see a little variance in the final results. So just to keep that in mind. If you're totally if you just want to see took time, don't care about the final results, go ahead. Yeah.
Any other questions? Yeah.
When you say data store, is it another index?
Yes. So yeah. So for now, it just supports OpenSearch, and it creates 3 different indices. One is called benchmark metrics that has the per second level data that you would want to use tracking live. And then it has another index called benchmark results and test executions. They mostly contain the final results that you see in the console.
And it's in the same cluster as my index? Or
No, I mean, we would not recommend you to. I mean, it can be if you're okay with that. It can be. It can be any data store cluster.
Okay.
Yeah.
Yeah, ideally you want your system under test to be separate.
To be separate from the
because you don't want to have your results getting affected by this kind of activities.
Yeah.
So I'm curious, what's the third index stored?
So benchmark metrics, benchmark test results, and benchmark results and benchmark test executions. I think these 3 are one. So each contain a different level. So benchmark metrics contain per second docs, and then benchmark results contain for each query a lot of P90, P50 docs for it, and then test executions basically mimics the final console output that you see.
Yeah, so any other questions with regard to performance or anything else in general would also be fine, and I think, yeah.
Can you customize the sampling if you want to do it per minute or something like that, or is it default hard-coded per second?
Sampling of what exactly?
When you're storing it into the...
Oh, it's customizable. Yeah.
Yeah, as I was saying, we have all the maintainers, Ian, Michael, and Rishabh of OpenSearch Benchmark in this room. So this is your opportunity to, ask any questions, either now or after the talk.
All right. Thank you.
Cool.
Thank you.
Thank you for attending.